Hello everybody, my name is Kiran. I am working as an assistant professor in the department of EEE Anits. I welcome you all to my 8th lecture under the first module of DC generators. In my previous lecture, we have seen what is armature reaction and what are the various effects of armature reaction and how can I remedy the effect of armature reaction. In today's lecture, we are going to derive the expression for demagnetizing and cross-magnetizing ampere turns per pole. So what are these demagnetizing and cross-magnetizing conductors? So the demagnetizing conductors are the conductors which are responsible for producing demagnetizing and distortion effects. So these conductors lie within the angle AOC and BOD, which carry the current in a direction to produce the flux in the opposite direction as that of main field flux. So you can see, so these are the demagnetizing armature conductors which are present in between the angle AOC and BOD. Coming to cross-magnetizing conductors, these are the conductors which are responsible for producing cross-magnetizing effect, and they lie between the angle AOB and COD, and they also carry current in a direction to produce flux opposite to the main field flux. So we'll see regarding cross-magnetizing conductors later. First, let us see the expression for demagnetizing ampere turns per pole. So let us consider Z to be the total number of armature conductors and I to be the total current in armature conductors, and this will be equal to IA by 2 in case of wave winding and IA by A in case of lap winding, where A is the number of parallel path. So if theta m is the forward lead in mechanical degrees, then total number of armature conductors in the angles AOC and BOD will be Z into 4 theta by 360. If I go to my previous slide, so you can see we have 4 angles, isn't it? This is theta m, so this here we have 4 theta m, isn't it? So out of 360 we have 4 theta m. So demagnetizing number of conductors will be nothing but Z into 4 theta m by 360. Okay, so these are the armature conductors, but if I want the number of turns in these angles AOC and BOD, it is nothing but Z into 2 theta m by 360, because we know one turn consists of 2 conductors. Since armature conductors are Z into 4 theta m by 360, and since I need number of turns in these angles AOC and BOD, just if we half the value of the number of conductors, that will give you number of turns in these angles. Next, demagnetizing ampere turns per pair of poles will be nothing but Z into I into 2 theta m by 360. So these are number of turns, isn't it? Z into 2 theta m by 360 is number of turns. I need ampere turns. So just if I multiply this by current, that will give me the number of ampere turns per pair of poles. But if I need demagnetizing ampere turns per pole, that will give me the expression ATD per pole, that is demagnetizing ampere turn per pole will be nothing but Z into I into theta m by 360. So this is the expression for demagnetizing ampere turns per pole. So in case we need to neutralize the demagnetizing effect, as I told you earlier, we need to invest extra number of turns on each pole in order to eliminate that armature or that particular effect. Okay, so if it is a shunt machine, if I need to find the extra number of turns per pole, then I can get that by dividing the ATD per pole, that is demagnetizing ampere turn per pole, by shunt field current. In case of series machine or series generator, if I need the extra number of turns per pole, I just need to divide by armature current IA. Okay, so this is when there is no information regarding the leakage coefficient. But if the leakage coefficient is given, then for shunt generator, the extra number of turns can be expressed as lambda into ATD per pole by ISH. And in case of series generator, it can be expressed as lambda into ATD per pole by armature current IA. Coming to cross-magnetizing armature conductors. So these are the conductors in between the angle AOB and COD. Okay, so here we have, so now we will derive the expression for cross-magnetizing ampere turns per pole. So the total number of conductors per pole is Z by P. Demagnetizing conductors are given by Z into 4 theta m by 360, isn't it? So if I need per pole value, it is just dividing by 2. So demagnetizing conductors per pole will be Z into 2 theta by 360. So from the demagnetizing conductors per pole, I need to find what are the cross-magnetizing conductors per pole. So these are the total conductors Z by P, and these are the demagnetizing conductors per pole. So if I subtract both them, that will give me the expression for cross-magnetizing conductors per pole as Z into 1 by P minus 2 theta by 360. If I want number of turns, so just I need to divide by 2. So cross-magnetizing turns per pole will be Z by 2 into 1 by P minus 2 theta m by 360. If I need ampere turns per pole, I need to multiply by current. So cross-magnetizing ampere turns per pole, ATC by pole will be ZI by 2 into 1 by P minus 2 theta m by 360. So demagnetizing ampere turns per pole is indicated by ATD per pole, and cross-magnetizing ampere turns per pole is indicated by ATC per pole. So this concludes my today's lecture on the derivation of expression for demagnetizing and cross-magnetizing ampere turns per pole. So we'll meet in the next lecture with some other topic. Until then, take care, thank you and goodbye.